Hello, Nafisa. We can start the session. You can unmute yourself and start the session.
Welcome, everyone. I hope I'm audible to everyone watching. Please do let me know if I'm audible or not.
Yes, Nafisa, you're audible.
Yes, yeah, you are.
Thank you for the confirmation. I, Nafisa Shams, on behalf of ASHRAE Falcon Student Chapter, Mahe Dubai, applaud the academic president, Dr. Jason Fitzsimmons, Dean and Chairperson, School of Engineering and IT, Dr. S.K. Pandey, Coordinator Mechanical Engineering, Dr. Rajiv Silvam, ASHRAE Student Activities Committee Chair, Professor Sampath Suranjan, faculties and staffs, and all the students for joining our session today on the most referenced ASHRAE standards in the UAE. If anyone's facing any issue viewing this session, please note we are going live on YouTube as well. You may find the link of the session in the chat box. Vivian, could you please share the link? Thank you. Before I introduce our distinguished lecturer, I have some exciting news to share with everyone present here currently. I'm immensely glad to announce that 2 teams from ASHRAE Falcon Mahe Dubai chapter who applied for the ASHRAE Undergraduate Program Equipment Grant was approved for the project scholarship for the year 2021 to 2022 by ASHRAE. Project 1 is Design and Fabrication of Rotary Type Humidifier in Arid Regions. Grant received $3,650 US. Student members are Mr. Srijit Sunil Kumar, Mr. Anthony Joan, Mr. Fabian Terence, Ms. Parvati Anil Kumar, and Ms. Nafisa Shams. Project 2 is Centrifugal Humidifier. Grant received $1,100 US. Student members are Mr. Ruben Francis DeCosta, Mr. Sahil Mahesh Shetty, Mr. Ananda Dhar, Mr. Vivian Christo Vincent, Mr. Peter George, Mr. Alan Matthew Charlie, Ms. Subiksha Sukumar, and Mr. Girish Varandaraj. Now, with great honor and delight, we have Mr. Hassan Yunus here with us today on this special occasion as our distinguished lecturer. Mr. Hassan Yunus is a remarkable talent contributing to the society. To give a little insight on his professional aspect, he is a co-founder and the CEO of Griffin and has over 15 years of extensive experience in the field of energy efficiency, design, sustainability, and project execution management. Mr. Hassan has been involved in many high-end projects in the MENA regions, encompassing MEP designs, energy efficiency, commissioning management, sustainability, and measurement verification for new and existing buildings in the MENA region. He also was involved in energy and sustainability policy studies for many government entities in the GCC. He is a trainer for ASHRAE Global Training Center. He is a trainer for Association of Energy Engineers Certified Energy Manager CEM course, Energy Valuation Organization Certified Management Verification Professional CMVP course, and the facilitator for the Emirates Green Building Council Building Retrofit Program. He is an appointed consultant for ASHRAE 62.1 standard and is a member of training committee for the CMVP course. He is also the current ASHRAE Falcon chapter president on the technical team, as well as previously the vice chair of SIPSI regional chapter. Mr. Hassan holds all the ASHRAE certifications. Mr. Hassan, it is time to dive into the main part of the discussion today. Please do let me know if you're ready to take over this space.
Thank you, Nafisa. Thank you, everyone, for joining today. Yeah, I'm ready.
All right, you may please go ahead. Thank you.
Thanks. I hope you can see my screen now.
Yes, sir, we can see your screen.
First of all, thanks everyone for joining. Thanks, Mai, for hosting this webinar. And congratulations for the teams who got the grant from ASHRAE. So our talk today is to describe, first talk about ASHRAE, give you more insight on ASHRAE, and then talk a little bit on the most referenced ASHRAE standards in the UAE. So I'm audible, everybody's seeing the screen.
Yes, sir. We can see your screen and you're audible.
Great.
All right, great. So let's talk about ASHRAE. ASHRAE was founded in 1894. It currently has more than 55,000 plus volunteer members. It's across 130 plus countries. It has 5,500 plus student members. Many of you on the call today are student members. It has 15 different regions, 190 plus chapters, and 400 plus student branches. Industry classification, you find consulting engineers, contractors, manufacturers, manufacturing representatives, government, health and education, design build, architects, scientists. So all these different stakeholders are volunteers within ASHRAE. They help in writing standards and all other stuff. Now let's start with the mission and vision of ASHRAE. The mission is to serve humanity by advancing the arts and sciences of heating, ventilation, air conditioning, refrigeration, and their allied fields. So this mission has been changed recently. The vision is a healthy and sustainable built environment for all. So although ASHRAE mainly talks about HVAC, but we also have a lot of emphasis on sustainability and other stakeholder activities. This is the 2019-2024 ASHRAE strategic plan. So the initiative area is built environment of the future. 1, resilient buildings and communities. 2, indoor environmental quality. And although this has started since 2019 with the COVID pandemic, we are more pressed now towards having a more healthy indoor environment. So ASHRAE has been pushing for this for some time. And now with the pandemic, we're all agreeing that we definitely need to work more on the indoor environmental quality. Organizational streamlining and improve chapter engagement capacity and support. That's more on the ASHRAE side of things, non-technical stuff. We want everybody to be engaged, chapters, and people who are basically members of ASHRAE to be able to participate in ASHRAE activities. If you want to know more, you can go to the website. This is the link, ashrae.org/strategic plan. Now, what are the ASHRAE core values? Commitment. ASHRAE and its members are passionate about serving the built environment, creating value, and recognizing integrity. ASHRAE is committed to the highest ethical standards, and us as engineers, ethics should be the first thing that we look at, and we always need to do business in an ethical way. As per the ASHRAE definition of integrity, we work transparently, observing essential requirements for due process and peer reviews to assure our members and stakeholders that we do the right things the right way. Another core value is excellence. ASHRAE education, technical information, and all other activities and products will always reflect the best practices that lead our country. We strive for continuous improvement and innovation in all our practices and products. Diversity. ASHRAE is committed to providing a welcoming environment. Our culture is one of inclusiveness, acknowledging the inherent value and dignity of each individual. Also on volunteering, members lead ASHRAE at every level, serving ASHRAE and helping ASHRAE serve society. So we are all volunteers. Actually, most of us are volunteers. ASHRAE has only like 128 to 130 staff members, and all others are basically volunteers. Even the president of ASHRAE is a volunteer, basically. Collaboration. ASHRAE seeks and embraces collaborative efforts with organizations, agencies, and individuals, sharing our commitment to sustainable built environment. So ASHRAE does collaborate with many agencies around the world, in North America and all around the world. So to name a few: CIPS, CISNA, ASME, a lot of different institutions around the world. RIVA, which is the European counterpart of ASHRAE. A lot of collaboration. between these organizations. Code of ethics and diversity commitments. We will act with honesty, fairness, courtesy, competence, inclusiveness, and respect for others, which exemplify our core values of excellence, commitment, integrity, collaboration, volunteerism, and diversity, and we shall avoid all real or perceived conflicts of interest. So that is our code of ethics commitment. In every meeting of ASHRAE, we start by saying the code of ethics, basically. Diversity commitment, ASHRAE is committed to providing a welcoming environment. Our culture is one of inclusiveness, acknowledging the inherent value and dignity of each individual. We proactively pursue and celebrate diverse solutions and strategies for the society and for the communities our society serves. We respect and welcome all people, regardless of age, gender, ethnicity, physical appearance, thought styles, religion, nationality, socioeconomic status, belief system, sexual orientation, or education. So ASHRAE is open for everyone, and diversity is at its core. As members of ASHRAE or participants in ASHRAE committees, we pledge to act with honesty, fairness, courtesy, competence. This is basically just emphasizing more on the code of ethics. And if you want to know more on that, you can just go to ashrae.org/code of ethics. And we're gonna send you this presentation to so you can have access to it as well. In terms of ASHRAE structure, this is how it is structured at the moment. So there's the ASHRAE membership, and then it feeds into different committees: the board of directors, executive committee, technology council, publishing education council, members councils. You can look at that as well, and that has been revised in April 2020. Every few years, I mean, depending on how things are going, things might change. So, but I mean, this is how it is for the time being. What we do at ASHRAE and how we do it: one, serve as pipeline for providing technical information to members, chapters, companies, and government officials. Two, develop standards and technical guidelines to improve the built environment, and this is where the world basically takes advantage of the offerings of ASHRAE, because ASHRAE has a lot of standards. We're going to see how many in a second. Three, offer continuing education for industry professionals. So we have courses. So ASHRAE does give courses. We have the Global Training Center in Dubai, which we're going to be talking about in a second. And four, serve as a networking tool for industry professionals during these meetings and similar meetings, the ASHRAE winter meetings that happen normally in January. Unfortunately, it was virtual this year because of the pandemic, but in general, it's a great venue to interact with different people from around the world. And then there will be also the ASHRAE Expo, that is one of the biggest expo in the world in terms of air conditioning. So ASHRAE has 33 standing committees, 130 standards and guidelines committees, 100 plus technical committees, 300 plus publications, 7 certification programs, 200 plus educational courses, and of course there's the research and scholarship. Now, why to become a member? Why do I really would advise anyone to become an ASHRAE member? There are many different benefits. So you have discounted ASHRAE Learning Institute courses. So if you are a member, you get a discount, I think around 15%. If you are also a member, you get discounts when you are you want to go for a certification exam, you get a discount on that. You have free online access to a very nice publication, which is Science and Technology for the Built Environment. You have member access to the technology portal, which has tons of information. You get a connection to 55 plus industry professionals around the world. You can get involved at the chapter, region, and society level, just like you're doing with your chapters, student branches. You have the monthly ASHRAE journal that has really good and nice technical articles, and will keep you up to date in the HVAC industry. There's annual edition of the latest ASHRAE handbook, so you get the handbook every year. So let's say if I'm a member, if I became a member now, I'll get the ASHRAE handbook, and you get 25% off in the ASHRAE bookstore. So there are a lot of benefits. That's why I would advise any person that wants to work in the built environment, whether you're an architect, mechanical engineer, electrical engineer, it is good to be an ASHRAE member. The benefits are really huge compared to the fee, let's say, you would need to pay to become an ASHRAE member. Another thing we have in ASHRAE is the Young Engineers in ASHRAE, the UAE. So that committee focuses on offering relevant programs and services to young professional ASHRAE members, 35 years old and younger. Unfortunately, I'm not a UAE anymore. UAE Leadership Weekends provide the opportunity for future leaders, and it happened in Dubai actually twice now. And it's basically kind of a gathering. I've been to one of them years ago, and it's gonna develop soft skills, networking with other young professionals. So you'll meet professionals from all around the world. There's also the Leadership U program, which allows a UAE member to shadow a vice president during winter annual conference. So you go with the vice president to all these meetings, you understand how things work in ASHRAE, so on and so forth. And also there are some scholarship for HVAC design essentials training. You want to know about more about UAE, you go to ashrae.org and /YEA. And of course, once you graduate, you become a member of ASHRAE, you are probably automatically will be a young engineer, and you can access all these extra resources. The ASHRAE Journal, really nice articles, very technical. It gives you, and very easy to understand. They're peer-reviewed, and they are easy to understand, written in a very easy language, let's say. So it does provide detailed insight on the latest technologies and applications to engineering professionals. Articles, like I mentioned, are peer-reviewed and focus on technical issues, including green buildings, indoor air quality, energy management, thermal storage, alternative refrigerants. These are few of the topics that are covered in the ASHRAE Journal. And being an ASHRAE member, you can access all of the ASHRAE journals since its inception. You have thousands and thousands of articles that you can access on different topics. So it's really a wealthy source of information that you can get from these ASHRAE articles. And it is emailed to ASHRAE Journal subscribers twice monthly, and it connects readers to the latest news and technical features. That's basically the newsletter that's done twice a month. That's different than the journal. That's a newsletter that has like different stories from around the world, different news from around the world that probably are of interest to anyone working in the environment. But the ASHRAE Journal, the main one, is the one that has the technical information. Newsletter is just like the name says, mainly focused on news. The ASHRAE handbook, so we have 4 ASHRAE handbooks. We have the fundamentals, we have the applications, we have the refrigeration, and the systems and equipment. And every year there will be a new version of one of these books that will be published. There's the online version where you can access all these books online, and I think we're trying to move away from the printed version. I think in the future probably we're going to only have online versions to reduce the amount of printing and to become more sustainable. So very good amount of information in there. On almost any topic in HVAC, you'll find one chapter in the HVAC in the ASHRAE handbooks. Now, let's talk about codes and standards. Why do we provide standards? They provide minimum safeguards for people with regard to building safety. That's why we started putting codes and standards, and mainly codes here. They protect health, safety, and welfare in the residential and commercial built environment. So when they decided to start putting codes, it was mainly to protect health and safety and welfare in the residential and commercial built environment. Looking at the history, I'm not sure if anyone can answer this question. What was the first code in history? You can send it on the chat box, but it was somewhere close to here. So the first code in history was the Code of Hammurabi. which was what is considered kind of the first code. And the part of the code says that if a builder builds a house for someone and does not construct it properly, and the house which he built falls in and kills its owner, then that builder shall be put to death. So that's kind of one of the, it's a bit harsh, but that's one of the first codes in history that relates to building and safety. So back then, probably whoever was building houses had to be very, very careful in designing and executing that job, because they could face a death penalty if something wrong goes in that particular house. Probably at that time, being an engineer was highly paid, but a bit dangerous. Standards, on the other hand, they're developed as extension of code requirements. They represent consensus on how a material, product, or assembly is to be designed, manufactured, tested, or installed to obtain a specific level of performance. So standards is there to help code. So in a code, you might refer to a standard saying, you need to design this part as per this particular standard. Now, some standards can turn into codes, and standards are typically narrow in scope. They will talk about one specific thing. They usually focus on a particular product or system. So you'd have a standard on, let's say, testing chillers, or a standard on testing pressure vessels. And the idea is to standardize items. Let's say you want to produce a certain equipment. You have a standard, and everyone would be following that standard. So you'd have, let's say, a plug on a wall that will look the same. It will always work. It's not going to work depending on where you buy it from. So since it's standardized, it is easier to produce and sell that product, and to make sure that it works. Health and safety has been checked from that end, and it basically will be easier to produce and distribute that particular product. Now, looking at the ASHRAE standards, these are the most well-recognized standards. There's the ASHRAE standard 15, which is the safety standard for refrigeration systems and designation and classification of refrigerants. ASHRAE standard 34, designation and safety classification of refrigerants. ASHRAE standard 55, which is thermal environmental conditions for human occupancy. 62.1, which is ventilation for acceptable indoor air quality. 62.2 is ventilation acceptable indoor air quality in residential buildings. ASHRAE 90.1 is the energy standard for buildings except low-rise residential buildings. And ASHRAE standard 188 is Legionella, risk management for building water systems. So basically, to reduce the risk of the Legionella bacteria in water systems and buildings. And we have the 2018 International Green Construction Code, which is based on ASHRAE standard 189.1. In North America, they've changed the 189.1 to be the International Green Construction Code, but 189.1 still exists to serve other countries. So these are the ASHRAE standards. As you can see, there are so many: 15, 16, 17, 18, 105, 225, many standards. But the ones that I've mentioned before are the most recognized worldwide. Now, in terms of the most referenced ASHRAE standards in the UAE, we have standard 15, the safety standards for refrigeration systems. That is basically a standard mainly for procedures for design, construction, installation, inspection, testing, and operation of the equipment and systems that use refrigerants. So basically, if you're designing a district cooling plant and you have big water-cooled chillers situated in a hole, and that hole could be occupied, so there's a danger of leakages. So the standard here will tell you how to design the system, that you need probably to have some audible alarm in case of there's any release of the refrigerant or there's any leakage. You would have sensors that would sound an alarm, and that would also, you have a visual alarm, because in chiller rooms, I'm not sure if you've been in one, but it's pretty noisy. So you might not hear the alarm sounding, but you will see. So you need to have both audible and visual alarms, and also you need to have an exhaust fan to take out that refrigerant from the room to the outside. You need to have some breathing masks. So in case there is a leakage, you would take that mask and use it. So there are a lot of requirements in there. Even if you have a normal, simple DX split unit, you need to look at the concentration in the room, because if there's any leakage in the room, that high pressure refrigerant can push the air from the room to the outside, and then that could suffocate people on the inside. So it's very important to look at the standard when you are designing anything that has refrigerant inside, especially refrigerant that is in occupied zones. The Standard 55, which is the latest one, was published recently. And this is the standard for thermal environmental conditions for human occupancy. This standard basically specifies the combination of indoor space, environment, and personal factors that will produce thermal environmental conditions acceptable to 80% or more of the occupants. So if you are designing a space, you want to select your temperatures and humidity, you probably would want to look at standard 55 and see the requirements. In general, we would use like 23 degrees C or 24 degrees C at 50% relative humidity. That's normally acceptable temperature and humidity. But there are also other things you need to look at, like thermal radiation. If there's someone sitting next to a window and there's a lot of sun radiation, he might not be very comfortable. So you need to look at that as well. Humidity, airspeed. You can probably tolerate higher temperatures with higher airspeed. So you can increase maybe the set point from 23 to 25 or 25.5. Still be comfortable if you have higher airspeed, and probably reduce your energy consumption because now you're operating at a higher temperature. The personal factors are those of activity and clothing. So depending on if you're in office, you're probably not, your activity level is not that high. So that will also reflect on your thermal comfort requirements. Clothing, if you are wearing heavy clothes, definitely you would tolerate lower temperatures, and so on and so forth. So it takes into account all these things, and you can use that standard to determine what is the optimum temperature and humidity and what needs to be done in the room for at least 80% of the occupants feel comfortable. So that's a very important standard, and it's deferred in Dubai municipality, Abu Dhabi municipality, and most of the municipalities around the UAE would refer to ASHRAE standard 55. That's a very important one, ASHRAE standard 62.1, which is ventilation for acceptable indoor air quality. Now this standard specifies minimum ventilation rates and indoor air quality that will be acceptable to human occupants. Especially now with the COVID, ventilation became very important. It was always very important, but now it's imperative to have good ventilation so that the viral load in a building is not that high. And we know that COVID could be airborne. So having enough ventilation will reduce the viral load, and that will reduce the amount of transmission, or would reduce the transmission rate. It's intended to minimize the potential for adverse health effects. This to be used to guide the improvement of indoor air quality in existing buildings. So this 2.1 is mainly intended for new buildings, but you can use the information that it has to improve existing buildings as well. In 6.2.1, there are many ways to comply with the standard. There's the natural ventilation way, but I mean, in the UAE, it's not, we don't have a lot of days where we can use natural ventilation. And there's the ventilation rate procedure, which is basically looking at the number of people inside a particular space and the area of that space. And then you go into a table and they'll tell you, let's say for an office building, it's 5 liters per second of outside air per person that needs to be supplied to that room, plus 0.3 liter per second per square meter. So you have the area of the room, you know how many people are inside, you can deduce how much outside air should be supplied to that room to satisfy the standard. There are other requirements like filtration. We know that outside air might have dust, might have some pollutants, so we need to filter it. The recommendation is to go for a minimum efficiency reporting value of 11 on outside air handling units. And now the recommendation from ASHRAE after COVID, maybe to go for 13. So there are some requirements on the way you maintain your equipment as well. Drain pans on the cooling coil, so you know that the cooling coil will start condensing that moisture and removing it from the airstream because you want to reduce the humidity in the room. But that water should not be stagnant, and on the drain pan it should be taken out from the drain pan, because water is kind of will allow bacteria to build, and this is something we don't want. Another thing that we look at in standard 62.1 is the exhaust and requirements. So it will tell you for toilet what would be the amount of exhaust needed. Also, it looks at air classification. So an office building would be a class 1 or an office space, whereas let's say a toilet, it will be class 2. The higher the class, the more concentration of pollutants is there, and you cannot mix between classes. If you mix, let's say, class 1 and class 2, automatically that whole air stream becomes class 2. So a lot of information on indoor air quality. The third way to be compliant with the standard, which is called the indoor air quality procedure, and that basically is a mass balance equations, and you will start with assuming what are the type of pollutants that are being emitted inside a particular space, and then you do a mass balance and see how much outside air you need to have inside that room to dilute the pollutants to a certain level. Now, this is not widely used because it takes more time and needs more experience, and it's not generally not acceptable in the UAE. So what in the UAE we mainly use the ventilation rate procedure, which basically tells you the amount of outside air that is required based on the number of people and the area of spaces. Now, one of the really important standards that I would advise you to start looking at as soon as you graduate is the standard 90.1, which is the energy standard for buildings except for buildings. This standard is mainly intended for new buildings and major renovation. It is a minimum energy efficient requirements for design and construction of buildings and their systems and equipment, as well as criteria for determining compliance with the requirements. So 90.1 looks at the different elements in a building that cause energy consumption to be higher. So we look at the envelope. So there are requirements based on the climate zone. So in ASHRAE, it's divided into 9 climate zones. So we have climate zone 0, which is very hot. And we are situated here in the UAE in climate zone 0. And there's climate zone 8, which would be parts of Alaska where it's really cold. And based on the weather or the climate, there will be a set of requirements. So the U value, the amount of insulation you have on the wall, the type of the window, the solar heat gain coefficient, the U value of the window will differ based on that particular climate. And how ASHRAE does that is that they do some kind of life cycle costing. They're not going to go with like crazy numbers that are not attainable from a technical point of view, and they're not feasible. So they will look at the market and come up with these decisions. Definitely year on year. So the first standard was in 1975. Year on year, every 3 years now, there's a new version of the standard. So, and every 3 years, probably it becomes more stringent. So it moves from the envelope to mechanical systems, HVACs, service salt water, motors, lighting, anything that really uses energy. 90.1 tries to put a target, tries to minimize its consumption by providing recommendations and requirements on how to design, what are the limits, what are the thresholds in terms of values. So let's say for lighting in an office building, shouldn't be more than, say, 10 watt per square meter of lighting. So if it's 100 square meter times 10, you cannot use more than 10 kilowatt of electricity, or 1 kilowatt of electricity in that particular room. So you multiply 10 watt per square meter times 100, it's 100 square meter times 10. That means 1,000 watt in that room. That means 1 kilowatt only is allowable to be used as lighting in that particular room. Some of the ASHRAE standards have what we call the user's manual. And the user's manual is basically kind of an explanation of the standards. If you want to understand more and look at examples, I would advise you to buy the user's manual. It has a lot of information in it, and it explains why the standard was written this way. And a lot of these standards, like 62.1, 55, they do have user's manual. I would recommend to buy them once you become practicing engineers to understand more on that. So these are the main ones that are referenced in the UAE. Now I'm going to move into the way standards are done. So you can review standards. If you go to public reviews, you'll find that some standards are available to be publicly reviewed. So any ASHRAE standard will go through public review for a specific amount of time, and then they get from the public some comments, and then these comments need to be addressed in order to publish the standard. So if you're interested in that, you can just go to ashrae.org/public reviews, and you can find the documents that need to be reviewed. You can even send them a comment if you want. Very important other publications are the Advanced Energy Design Guides. These are really nicely done. They started with 30% more efficient design guides than 90.1, then they moved to 50%, and now we have the net zero guides. And for the net zero, we have the school buildings. So it tells you, based on your climate, the things that needs to be done to achieve net zero energy, which is the only way to be able to curb the thermal or the climate warming, the global warming that we are facing, is to start building buildings that are net zero and start transforming older buildings into net zero energy buildings. Another one that was published is the Advanced Energy Design Guide for small to medium office buildings, which is basically 1,000, 10,000 square meter buildings with a height of less than 75 feet. And there's one for multifamily residential buildings achieving net zero, which is in development and will be coming soon. Since we started, COVID started, ASHRAE. Yeah. Is there any question?
No question, sir. You can proceed.
All right. So, since COVID started, ASHRAE started a task force, and that task force exists to maintain communication with members, industry partners, building owners, facility operators, government agencies, and the general public. The Epidemic Task Force has created resources to respond to the current COVID-19 pandemic. So they've created many resources depending on the building typology. They will, let's say if you have a school, they'll tell you how to operate, to reduce the mitigation, how to reopen the school after shutdown and after the lockdown that we had. So if you're interested in that, you can go to ashrae.org/COVID-19. There's plenty of resources on COVID for different building typologies. You are students now, and you'll always be students. We are all students. We keep on learning stuff, and one of the best resources available is the ASHRAE Learning Institute. There are many, many courses available, and I would advise you to look at the ASHRAE Global Training Center in Dubai. That's basically serving the MENA region. What we have here are many, many courses. Some of the courses are shown here on the right side: commissioning, data center. We had the HVAC level 1 course. I would advise that you need to check the HVAC level 1 and HVAC level 2. These are very, very important. If you want to work in HVAC in any way, shape, or form, these two courses are very, very important to attend. And then there are different courses on different subjects, whether it's high performance buildings, hospitals, commissioning, so on and so forth. ASHRAE e-learning, so there are some courses that, the course I was talking about where these are instructor-led courses. The ones on this particular slide are e-learning courses. So they basically, you would go and create a login, you pay for the courses you want to attend, and they're basically going to attend them anytime you want. And they just basically give you some resources to read, and then it's more of an interactive session, let's say, where there's like some questions they need to answer, and they basically like pre-recorded kind of interactive animations that you look at. It's also good courses. There are good courses, and they're not very expensive and give a lot of information. So it's something also wise to look at. ASHRAE certification. To get recognized, and probably 3 years down the line after you graduated, you maybe start with a certified HVAC designer, and then some of the other might need more than that. They need up to 5 years of practicing a certain topic. And there are 7 certification programs now. So they have the building commissioning professional, building energy assessment professional, that's mainly for existing buildings, building energy modeling professional, certified HVAC designer, high performance building design professional, healthcare facility design professional, and operations and performance management professional. So these basic certifications, you can currently join them online. So before you needed to go to a certain center. So there were a couple of these centers in the UAE, but now you can do it from home, basically. And although now you won't be eligible to take the exam, but in the future, I would recommend to take 1 or 2 certifications, gonna give you an edge over competition. That was it for me. Thank you very much for joining. And if you have any questions, please do let me know.
Thank you, Mr. Hassan, for sharing your precious knowledge and information on the topic, most referenced ASHRAE standards in the UAE. Now, shall we invite some questions from the audience? Please feel free to type it in the chat box if you're not comfortable unmuting your mic. Thank you.
Good afternoon, sir.
Good afternoon.
Yes, sir. Sir, I got a question. Sir, right now it's the time for net zero buildings and net positive buildings coming up. So I want to know how practical it is currently, with the current technologies available, and how practical it is.
That is a very good question, and many tried to answer. One of them being ASHRAE through many research projects. So, as you can see, the school, the offices, we already have ASHRAE guidance on how to achieve net zero in these particular buildings, and these are available for free. You can go and just Google AEDG. Let me show that particular slide. So the Advanced Energy Design Guide, you can go and just Google Advanced Energy Design Guides, or just go to this website, ashrae.org, this link, /free AEDG, and you can download these 2 guidelines on how to achieve net zero. How is it practical? It also depends on the climate. So the harsher the climate, probably the harder it becomes. Since we are in a harsh climate, high-rise buildings will have a tough time to become net zero energy buildings. So we probably would need to look at a whole city net zero energy, because some of the buildings that are, let's say, 1 floor, these are easy to convert to net zero because we have enough space on the roof to add photovoltaics that will kind of reduce the or counter the consumption that we have in the building. So first of all, to become net zero, we need to look at how to reduce our consumption. Before adding PV, we need to look at the efficiency. The load, like what is the load coming from? So for HVAC as an example, which accounts to maybe 70% of a residential building consumption, we need to have probably very good insulation. So if it's an old building we want to retrofit into a net zero, probably it would be a good idea to look at insulation, because older buildings did not have proper insulation. Not until 2004, 2005, where buildings in Dubai, by law, they required insulation. Before that, didn't have to. So it was up to the designer. So one thing is to look at the envelope, have good insulation, changing probably the windows into a more efficient, low U value, low solar heating coefficient. And then look at that load and see how we can provide that particular cooling requirement with very high efficient equipment. So we look at very efficient chillers, very efficient air conditioning units to serve that load. We look at the lighting, we reduce the amount of lighting that's required, and we reduce the amount of time that these units are turned on. So if there's no one in the building, we probably would need to have some kind of sensors that will trigger the control system to manipulate and change the set points to make sure that we are still in good thermal comfort. We're not, damaging the building fabrics because of high humidity, but at the same time, we're not overdoing it. So the minimum amount of energy that is required to be thermally comfort is what we need. So from that end, we reduce the amount of time and amount of load as well. Then the last step would be to add the renewables. Once we have squeezed the energy consumption, then we think about photovoltaics, because it is more expensive and it will take more time to get to the payback. So the payback on PVs is still a little bit high compared to, let's say, energy efficiency. Now, is it technically viable? Yes, there is a standard or a research project from ASHRAE, and that's a good thing about being a member. You can download all these research projects, research documents and reports from the website for free. So one of the reports or research projects was to look at the available technology and see if we didn't have, let's say, a budget, how good would we be in terms of energy consumption? How much can we reduce? And it showed on many buildings, let's say, and one of the climates was Riyadh in this particular project from energy modeling point of view. And we saw that you can save up to 70% of energy on office buildings and residential. So it is achievable, and but it costs a little bit more. So we need to be we need to acknowledge that it will take maybe 10 years or even more to get back that investment. But it's definitely technically viable, and these particular two publications will tell you exactly how to do it. The higher the number of floors, the more difficult it becomes for a single building to become a net zero. So 1 floor, 2 floors, 3 floors, 4 floors, that's still achievable. Anything beyond that becomes a little bit of an issue, because you don't have enough space on the roof to put the PVs. And then we need to think about like a district. So some of the district, let's say, will have high-rise buildings, some of them will have low-rise buildings. So we need to kind of use most of the available space to put the PVs. I hope that answers the question.
Yes, sir. Oh, definitely it answers the question. Thank you, sir.
Sir, there's another question from Raj Pandey. He asks, he wants to know about the role of ASHRAE in the aerospace industry.
In the aerospace, I don't know, honestly, if there's any role at all. I'm sure that there is a role in the aviation industry, because we have a standard on air conditioning in airplanes, but air conditioning in like space shuttles, I'm not quite sure. I haven't seen anything on that. That's quite interesting. Like when they design these, let's say the International Space mission and these shuttles, and what is like, how do they design the air conditioning system? That's interesting. But I'm not sure. That's a good question. I'll have to get back to answer that. I have to look into it. But for sure, for aviation, that is a standard and a chapter in the ASHRAE handbook that tackles the requirements in terms of air conditioning in aviation. But for aerospace, I'm not really sure.
Thank you, sir.
Hello. Good afternoon, sir. Good afternoon, sir.
Yeah, good afternoon. How are you?
This is Sampath here from Manipal, Dubai. Sir, can you elaborate more on ASHRAE Standard 55?
ASHRAE Standard 55. So ASHRAE Standard 55, it has actually got some changes in 2020 version. So in the Standard 55 2017 and before, we had a graphical method. So there's a graph, like a psychrometric chart, that showed where are the places where people will be comfortable. And it was divided between the 0.5 CLO, which is kind of the clothing level, and 1 CLO. And there's like a part of the psychometric chart, well, it works, where the standard says, yes, 80% of the occupants will be satisfied in that particular zone. So what we normally use as designers, look at that in general and say, well, the 24-50% is where the 0.5 and the 1 will be satisfied. This is why normally designers tend to go with the 24-50%. There are other elements in the 55 that people generally don't look at, like thermal radiation, airspeed. These are where things are not taken seriously by designers. So there is a need in the market to understand more on that standard, and it's not pretty straightforward, especially on how to calculate these things, because some of them might need to be done based on measurements. So you might not have that information during design. So you might assume something, and on site it becomes different. But as designers, we need to understand the basics, which are putting people next to a fully glazed window. Whatever AC you're going to provide, they're not going to be feeling comfortable unless they're going to put a blind or something. Putting a blind, you're kind of killing the views. So architects, interior designers, and mechanical engineers should work together to come up with a solution that will be workable for everyone. But in a nutshell, the 55 will look into temperature, humidity, thermal radiation, airspeed, and what is the kind of activity you have in that particular space, and what is the clothing level. So these are the 5 things that the standard will look at. And based on the activity level, the clothing level, there will be recommendations for what should be the temperature, what should be the humidity, and what should be the airspeed. As an example, before we couldn't, with the graphical method, there's analytical method and graphical method. With the graphical method, above 12 grams per kilogram, you can't use the graphical method. You need to use the analytical method. And most of designers would use the graphical method and would normally choose 24 to 24 and 50% relative humidity. I hope that, we can have another session just on that particular standard. And we do in the level 1 and level 2 design trainings, we do, cover this in more detail.
Thank you so much, sir.
Are there any more questions? If there are no more questions, we will continue our session. Mr. Hassan is extremely supportive for all the events, and even with his busy schedule, he finds the time to attend our event and support and encourage it. His expertise is a great way for us to get a better understanding of the various standards used by the industries and the other establishment for increased efficiency and performance sustainability. With this, I would like to conclude today's seminar on the most referenced ASHRAE standards followed in the UAE. Before ending today's session, let's have a glimpse of an upcoming event, EnergioMex, hosted by ASHRAE Mahe Dubai. which is anticipated by many, and it is one of the most awaiting event this academic year. Anthony, could you please share the promo for the event with us? Thank you. Please follow us on our social media accounts to register for the competition. And you can DM us on any social media platform for more information. Thank you once again, Mr. Hassan Yanis, and to everyone attending diligently. I hope everyone has a great day and stay safe.
Thank you, Maya Dubai. Take care. See you in the next event.
Thank you, sir.
Thank you, sir.
Thank you.